Compared to element 2, element 1's atomic radius is definitely smaller, probably bigger, or definitely bigger. Well, if we look at shielding, this factor increases atomic radius. So if element 1 has a larger shielding experience, then that's evidence that element 1 has larger atomic radius than element 2. Effective nuclear charge, on the other hand, decreases atomic radius. So the fact that element 1 experiences more effective nuclear charge than element 2, effective nuclear charge, on the other hand, decreases atomic radius. So the fact that element 1 experiences more effective nuclear charge than element 2 is evidence that 1 is smaller than 2. Both pieces of evidence support different situations, with shielding pointing to 1 being bigger and E and C pointing to 2 being bigger. So how are we going to reconcile this contradiction? Well, it just so happens that when it comes to impacting elemental properties such as atomic size, shielding is far more impactful than E and C. So it's more likely that 1 is bigger than element 2 on the sole basis of shielding alone, still acknowledging that the E and C difference between 1 and 2 could be really big and shielding difference really small. So the answer is probably bigger, but it's not definitely bigger. Here's a new set of elements. Compared to element 2, element 1's atomic radius is definitely smaller, probably bigger, or definitely bigger. For shielding, element 1 has less shielding than element 2. So that's evidence of 1 having a smaller radius than 2. E and C is larger for 1 than it is for 2. And since E and C decreases atomic radius, that's also evidence that 1 is smaller than 2. So both pieces of evidence tell us that element 1 should have a smaller atomic radius than element 2. So we can definitively say that element 1 is smaller than element 2.